Hi students, how is everyone doing? I hope yesterday's lecture was informative but at the same time quite easy for you, because it's only going to get harder with every single lecture. That means we have to find everything so far easy enough that we can deal with the harder things. Okay, so just tell me if the video is fine, the audio is fine. And students, there's something I would like to add, something I always tell all my students, that your one rule for any class you attend, whether it's your school, your coaching or a free YouTube class even, you should have this one rule, that there should not be a single line that you do not understand. Everything that happens in the class, everything that your teacher says, no matter what you're trying to learn, you should be able to understand everything. If that is the goal you go with in the class, then it just saves a lot of your time when you go back and try to study it on your own. Because if you study, if you learn half of the things in the class and then you have to do all of it again on your own, it just takes double the amount of time. But if you make sure that you have 100% concentration in class, you try to understand everything that is going on, then you do not really have to study it all again. You can just revise and then move on to practice. So that should be, especially for maths, it should be your rule. No matter what class you're attending, you should aim to understand 100% of it. Okay, don't be satisfied until you understand 100%. I will keep reminding you of this, but make sure that is your goal. Okay, so there are some requests for me to take these classes a little later, because maybe you just came back from school, maybe you come back from school a little after 3 and you want to have lunch and then sit for studying. I get it, I'm sorry, but I have other classes and I am making time. This is the best time I could find, but if I can, for any day, if I can find time after 4, I will. I promise, and you will be informed in advance. I do care about you. I do want a lot of you to attend, all the sincere students to attend, and if timing is a problem, then definitely I will try my best to fix it. But sadly, I have other batches, other classes, and they are just as important. So whenever I can find time, I will definitely schedule it for later. Okay, but in case you miss some of it, the recordings are available throughout. You can refer to them anytime you want. You can watch it at any speed you prefer. You can re-watch it to understand something that maybe you missed during the class. So the recordings are there for you for whenever you need it. Okay, so let's start. I think all these students are ready now to start. Let's go. So before we start today's lesson, I just want to do a quick revision of factorial. I think most of you are familiar with what factorial is, what this operation is, but just a quick revision, it's very easy. It just denotes the product of all natural numbers until the given natural number. So if we want to find n factorial, we just multiply all the natural numbers starting from 1 up to n. So 1, 2, 3, 4 up to n. Simple. So for example, if we want to do 5 factorial, we will multiply 5 into 4 into 3 into 2 into 1. All the natural numbers from 1 to 5. So 120. 4 factorial similarly would be 24. 3 factorial, so we can find any numbers, any natural numbers factorial given this. But what about 0? We were starting from 1 and we were stopping at the given natural number. We were going in an increasing order, but what about 0? So if you want to memorize, 0 factorial is also 1, same as 1 factorial. So that is how we define it. But I know you students do not just sit back and just memorize things. You want to understand how, right? How is 0 factorial 1? It's very simple. See, if you notice a pattern between 5 factorial and 4 factorial, all these numbers are the same. The only difference is 5 which means we can write 4 factorial as 5 factorial divided by 5, right? It's the same thing. Similarly, we can write 3 factorial as 4 factorial divided by 4. 3 factorial divided by 3, that is how we can write 2 factorial. Similarly, 1 factorial becomes 2 factorial divided by 2. So by that logic, what is 0 factorial? One natural number, one number above 0, its factorial divided by that number, right? For 1 it was 2 factorial divided by 2, so for 0 factorial it will be 1 factorial divided by 1, which is 1 by 1, which comes out to be 1. So this is how we define factorial. I hope this is very easy, just the product of all natural numbers starting from 1 until n. Okay, now we can start today's lesson. So for today's lesson, we want to solve this kind of problems when we are trying to arrange our objects out of n available objects. So we have in total n objects. It can be letters, digits, any kind of thing. Books, people, it can be anything, but we have n objects and we want to take r out of them and arrange them in all possible ways. So how many ways are there to arrange our objects out of these n available? If you remember, we already solved one problem like this yesterday. What did we do? We had 5 digits. So n was 5. We had 1, 2, 3, 4 and 5. And we were trying to form 4-digit numbers out of this, right? So r was 4. So we had to take 4 digits out of these 5 available digits and we had to form a number with that. So we could arrange these 4 digits in any way. So we had to find how many numbers, how many ways we can arrange 4 objects out of these 5, right? Which means, I hope you all remember how we did it. We had to fill 4 places and for first place we had 5 options. When we cannot repeat, then the next place we had only 4 options and 3 and 2. This is how we did it. So similarly, if it's n and r, in that case, for first place we have n options. For the next one we have n minus 1 and like this till the rth place we have n minus r plus 1. It keeps decreasing by 1, 1, 1, n minus 1, n minus 2. It keeps decreasing by 1 for each place, right? 5, 4, 3, 2. Similarly, for second place it was n minus 1. For third place it was n minus 2. So 1 less than this. So for rth place it will be n minus r minus 1, which is n minus r plus 1, right? So if we multiply all these numbers, we will find all the ways that we can arrange our objects out of n available objects. Now, we have something like n minus 1, n minus 2 up to n minus r plus 1, right? Starting from n minus r plus 1 up to n. We are multiplying all these natural numbers. If we multiply, what will be the next number? One smaller number after this, n minus r, right? Because this is 1 plus n minus r. So next number will be n minus r, then n minus r minus 1 up to 1. If we multiply these numbers, in the numerator we also have to divide with the same number. We can't just multiply with numbers, right? So we will multiply both numerator and denominator with this product. Now what is this product? This is product of all natural numbers starting from 1 up to n minus r. So that means this denominator is nothing but n minus r factorial. Similarly, numerator, it is the product of all natural numbers from 1 till n, right? Because we took 1 to n minus r and then n minus r plus 1 up to n. So this is n factorial. So the number of ways of arranging R objects out of total n available objects is n factorial divided by n minus R factorial. And we define this as NPR. So NPR is equal to n factorial divided by n minus R factorial. Alright. So if we apply this formula to our previous problem, we had 5 digits and we had to take 4 out of these 5. So the answer should simply be 5p4, which is 5 factorial divided by 5 minus 4 factorial. So 5 factorial divided by 1 factorial, which becomes 120 by 1, 120. And this is the same as the answer we got yesterday. This is the same as the answer we got just now. 5 into 4 into 3 into 2, that is 120. Okay, so we can directly do it because this is only possible when we have a small number of places to fill, right? But if it were, let's say, 100 digits, we cannot keep writing all of this. We cannot multiply all of this. In that case, we will need some sort of a formula. So this formula comes in handy. Okay, so when we are given R, we are given n objects and we have to take R out of them and arrange them. The number of ways of doing that is NPR, which is equal to n factorial by n minus R factorial. Now let's take a look at a few examples. So we have 3 seats and 5 passengers. In how many ways can these 3 seats be filled with 5 passengers? Assuming only 1 passenger per seat, okay, no one has to adjust, no one has to compromise, only 1 passenger per seat, then so we only have 3 seats available and 5 passengers. So what will be the answer? Okay, so the answer will be 5p3 because we had to take 3 passengers. We had seat 1, seat 2 and seat 3, right? 5 passengers. So out of these 5 passengers, we have to take 3 and arrange them in these 3 seats. They can be sitting in any order. So we have to take all the orders into consideration, which means 5p3. So 5 factorial by 2 factorial, which is 120 by 2, 60. Simple. So how many 3-digit numbers can be formed with only odd digits without repetition? Very important. Without repetition, how many odd digits do we have? 1, 3, 5, 7 and 9. These are all of the odd digits that we have. We have 10 digits. Out of those, 5 are odd, 5 are even. So 5 odd digits, we have to choose 3 out of them and arrange them to form a number. Since 0 is not here, we don't have to worry about that case, which means we can choose any 3 and arrange them and we will have a 3-digit number. So simply it again becomes 5p3 and we just calculated the value of this is 60. Simple. Now, how many 4-letter words can be created using the letters of the word algorithm? Words may be meaningless. We just want to form a word that means a sequence of letters. It doesn't have to have a meaning. It can be meaningless. That means if we have something like LGRO, it doesn't mean anything, but it still counts as a word. So how many arrangements of 4 letters out of these given letters can be there? Now let's first count how many letters do we have. What is that? N, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means out of these 9 letters, we have to choose 4 letters to form a word, and to form a word, we can have any arrangement. So R becomes 4 and the answer is 9p4. If you want to calculate, this just becomes 9 factorial divided by 9 minus 4 factorial, which is 9 factorial by 5 factorial. So you're not going to calculate the entire thing, the entire 9 factorial. You will just write 9 into 8 into 7 into 6, and then the rest is 5 factorial divided by 5 factorial. So we'll just cancel 5 factorial and 5 factorial. Now we only have to multiply these 4 numbers. So what does it become? A lot of calculations, right? So this becomes 9 into 872 into 7, 504, and 504 into 6 is 3024, if I'm not wrong. That's what you get. Right? Okay, so the calculation part is something you can easily handle. We just had to make sure that we have 9 different letters, right? We have 9 different objects. These are all distinct letters, which is why we can do this. So 9 distinct letters. Now let's take a look at an example, a problem which is solely based on the formula n minus 1 PR r into n minus 1 PR minus 1. What will be the answer? Just expand these. What does it mean? N minus 1 PR is n minus 1 factorial divided by n minus 1 minus r factorial plus r multiplied by n minus 1 PR minus 1. So n minus 1 factorial divided by n minus 1 minus r minus 1 factorial. Right? Which option is correct? Try to see what you can take common out of both the terms, how you can have the common denominator and multiply. Just try it once. I'll give you a few seconds. I know you can do it very quickly. You guys are very smart. I can already tell how you are solving each question just like that. So I'll give you a few seconds. Do try and tell me the correct option in the chat. So yes, that is amazing. Option B is correct. Let's see how. So this is n minus 1 factorial divided by n minus 1 minus r plus r multiplied by n minus 1 factorial divided by n minus 1 minus r plus 1. So 1 gets cancelled and this is n minus r factorial. Now n minus 1 factorial we can take common out of both the terms, right? So this is n minus 1 factorial. Now we have these two denominators. If you look at it closely, this is n minus r factorial and this is the factorial of one smaller natural number, just smaller natural number, because this is n minus r minus 1, right? So this is one smaller natural number than this. So we will take the larger one, that is the LCM of it. So the denominator becomes n minus r factorial. How will we make this n minus r factorial? By multiplying numerator and denominator with n minus r. Now n minus r into n minus r minus 1 factorial becomes n minus r factorial. Now we can simply take the denominator common and the numerator from first term is n minus r and from the second term it is plus r. So r gets cancelled. N into n minus 1 factorial is nothing but n factorial. So this is n factorial divided by n minus r factorial, which is nothing but npr. Okay. So any of these questions you can just solve by expanding, by looking closely what we can take in common, how we can form the same denominator, what should be multiplied so that, just like LCM, what should be multiplied so that they both have the same denominator. Okay. Now, in case we had to take all n objects out of the n available objects and arrange them. Earlier we had to pick a certain number r out of those, but if we could take all of them, we had to take all of them, all n of them, and then arrange it. In that case, r becomes n, which means npr is nothing but npn. So that is n factorial by n minus n factorial. So n factorial by 0 factorial. 0 factorial is 1. So the answer is n factorial. Okay. So what does that mean? If we are given n objects and we have to just arrange them. Now this is kind of stupid to say we have to take n objects out of them and then arrange them. That just means we are given all n objects and we have to just arrange them. We have to find all possible arrangements given n objects. So for example, if we had 1, 2, 3, 4 and we had to form 4-digit numbers, that means we have to use all 4 of these because no repetition is allowed. Without repetition, we have to form 4-digit numbers out of these 4 digits. That means we have to arrange these 4 digits. The number of arrangements is the number of numbers we can form. So that will be 4 factorial. If you just want to confirm using yesterday's method, you easily can. We have 4 places, 4 options for the first place, 3 options for the second place, 2 options for the third place and 1 option for the last place. 4 into 3 into 2 into 1 is nothing but 4 factorial. Okay. So now we have Delhi. The word Delhi, we have 5 different letters. We have to arrange these letters to form different words. If we are asked how many different words we can form using these letters, that means how many arrangements of these 5 letters can be done, right? So because words can be meaningless. So this is nothing but we are arranging 5 different letters in all possible ways. So this directly comes out to be 5 factorial. So using these 5 different letters, we can form 120 different words without meaning that will only have these letters without repetition. Now, how many numbers of 5 digits can be formed from the numbers 20537? Now we remember earlier we just had to make sure that 0 cannot be in the leftmost position, otherwise it will be a 4-digit number, right? So we remember yesterday's method. Now let's take a look how we can do it much quicker using permutation. So we can form, if we for a second, let's ignore about the 0. We have given 5 different digits. How many arrangements are there? 5 factorial. But these will also have the arrangements where first place, the leftmost position has a 0, and then these 4 digits can be anything out of 2, 5, 3 and 7, right? So how many numbers like this can be formed? We have fixed 0 in this position. That means we have to arrange 2, 5, 3, 7, 4 digits in these 4 places. That is nothing but 4 factorial. So out of these 5 factorial, all the possible numbers, we just have to exclude these 4 factorial numbers. The rest are fine. The rest do not have 0 in the leftmost position. So that is an acceptable 5-digit number, right? So that means 5 factorial minus 4 factorial, which is 120 minus 24, 96. If you want to confirm, we can quickly check that as well using yesterday's method. There are 4 options for the leftmost position, then remaining 4 for the second, and then 3, 2 and 1. So 4 into 4 into 3 into 2 into 1 is nothing but 4 into 4 factorial, 4 into 24, 96. Okay? So that is why this is much faster. Right now we are just trying to understand, so this still took us a few seconds, right? But once you get the hang of it, this is nothing but a 5-second problem. Okay. Now, words are created by rearranging letters of the word table. 5 distinct letters, words can be arranged, letters can be arranged. So how many possible arrangements? 120, right? 5 factorial. So 120 total words possible. Now, these 120 words are arranged alphabetically, right? In an alphabetical order as you would find it in a dictionary. Then, what is the position of the word table? Out of those 120 words, what is the position of the word table once we arrange them alphabetically? Okay, I see a doubt in the chat. Let's take a look at it. Sure, of course. So I see a doubt that we are only arranging 4 digits and we are finding the permutation of the digits. So how can it be 0? See bache, we have, if we arrange all these 5 digits in any way, we don't care if it's forming a 5-digit number or a 4-digit number, we are just arranging these 5 digits in all possible orders. So let's say one of them could be 2, as it's given 20537, one of them could be 20573. Like this, 120 permutations are possible. Out of these, some will be like this, right? Where the leftmost position has a 0, which is not allowed because we need numbers of 5 digits, a 5-digit number, right? So this ends up being a 4-digit number, which is not allowed. So out of these 120, we are excluding the ones which look like this, which are essentially 4-digit numbers. How many 4-digit numbers can we form? For that, we have to put 0 here and then 2537. We have to arrange these, all possible arrangements, which is 4 factorial. So as we arrange these, we get all possible 4-digit numbers. So total 24. Out of these 120, 24 will look like this, which has 0 in the leftmost position. So you just exclude those. We don't count those 24 numbers. The remaining 96 numbers are the 5-digit numbers that we were looking for. I hope this helps. If you're still stuck after this class, just sit and think about it on your own. I'm sure you will get it. Now, back to this question. So, okay, 97, 98. Let's see how to actually approach this problem in the perfect way. So, first step is, if we're talking about arranging it alphabetically, let's first see what comes first. We arrange these letters T, A, B, L, E, these 5 letters alphabetically. So, the first one will be A, then B, then E, then L, and finally T. Right? This is the order. We don't care about the meaning, so it doesn't matter if T comes first, A comes first. We will see all possible arrangements of these 5 letters, and we know A comes first, then B, then E, then L, then T. Now, when we arrange all these 120 words, the first words, the top words will have A as their first letter, right? That means we have to first count how many words are there which start with an A. So we have fixed A in the first position. How many words, how many letters do we have to arrange now? The remaining 4. So how many words, just like before, how we were arranging these 4 digits after fixing the first digit as 0. Similarly, once we fix the first digit as A, now it's just 4 factorial. So 4 factorial, 24 words are there in out of these 120 words which start with an A. Similarly, next will be B. These words that start with B, these will again be 4 factorial, so 24. So up until now we have 48 words, right? Then comes E. Again, table is still not anywhere here, right? So we still have to count all the words that are there before table. That means we will count now the words starting with an E. This is 4 factorial, again 24. So the words up until now become 72. 24 plus 24 plus 24, 72. Then next L, again we haven't reached table. So L, again 4 factorial. So now the count is up to 96. Now we have reached T. Now we can't count all the possible words, right? Now we have to find table. So now we again do the same process for the remaining 4 letters. So just like before, the first, as soon as we start with the words that start with T, the first few words will have A as the second letter, right? But we are also looking for a word that has A as the second letter. So we're not going to count how many words are there. We know 3 factorial yani ki 6. 3 factorial, that is 6 words, right? So 6 words are possible which start with TA. But we're not going to count all of them because we are looking for one of those words, one of those 6 words. So next comes after A, B. Again we are looking for such a word. Then after that we have, what are the 2 letters remaining? L and E. First comes E, which is not what we're looking for. So this will be the 97th word. And finally TAB, LE, this will be 98th word. So the correct answer is 98. What is the position of the word table? 98. Clear? So yes, this is how you tell the position, the rank of the word table. Once we arrange all of the possible words alphabetically with or without meaning, then this is the rank. Let's take another problem like this. Very similar method. I want you to try the same method. First arrange the letters alphabetically and then form the words, see which position random is at. Okay, I'll give you a minute or so. I'm waiting for your answer. But I hope you all know by now how to approach this problem, how to actually start and reach the word random. So 98 is the 619. I think it's close from, but we'll see. Just recheck your calculations, see if you didn't miss anything, see if you didn't count anything twice. You check the order correctly, and if you're sure, we'll see in a minute. Okay, so someone is saying 619, someone is saying 618, very close numbers. Let's see. So, first step is to arrange all these letters alphabetically. So, first comes A, then B, then M, N, O, and then R. Right? We have arranged all these 6 letters alphabetically. Now, just like before, we start with A. And now we have 5 possible letters, right? 5 remaining letters that we have to arrange. So that is nothing but 5 factorial, 120. Then comes D. So for D again we have 5 factorial, which is 120. Then M, again 5 factorial, 120. N and O similarly, because R is the last one. So for N we have 120, for O we have 120. So 120 into 5, 600. Up until now we have 600 words that do not start with R, right? Now we have to look at the words that start with R. So what was the order? A, D, M, N-O-R. Right? Now we start with R. That is fixed. We're looking for the word random. So the next letter will be A, which is what we want. Next will be D. Right? We're going alphabetically. Now we have 3 remaining letters. We have to find all the possible arrangements for these 3 letters. So that is 6. Then after D comes M. Again, we haven't reached N. So we'll count all possible words. So this is again 6. So we had up until now 600. Now we're up to 606 and 612. Right? Now comes N. Once we have N, we can't count all the words. So what will be the next letter? We have picked A, R, N. So what will be the next alphabetical letter? D, which is again what we're looking for. Then we'll have M and O. The first order will be M, O and then O, M. Right? So now this word will be R, A, N, D, O, M, which is what we're looking for. So this was 612. That means this is 613 and this is 614. So the rank of the word is 614. So bachas, I see a lot of 614. That's amazing. But if you were getting some other numbers, maybe you missed something, maybe you added something, maybe you got confused in the order, the alphabetical order of the letters. Either way, just be very careful, learn from your mistakes and make sure you never repeat them. Okay? But a pretty straightforward way. Yes, we have to count all of them. We have to go through this process. In a lot of these PNC problems, you will have to consider all cases. But a very important thing to remember here is go in an order so that you don't miss any case, you don't count any case twice. You get the right answer and you are a little smart in calculating the number of cases. Okay. Now, this was when all our N objects were distinct. What if they are not distinct? What if some of them are identical? For example, here we have total N objects. Out of this, P are of one kind. P objects are identical to each other. Q objects are identical to each other but different from P. And then the rest R are all distinct. So P are alike of one kind, Q are alike of second kind and R are distinct. For example, if we had the letters, let's say we were doing the similar problem as before, but now our word is, instead of random, it's arrays. Now we have 2 A's, 2 R's, and then this is how we arrange them alphabetically. Now we have 2 of one kind, 2 of second kind, and then 2 are distinct. So in this case, P is 2, Q is 2, and R is also 2. P of one kind, Q of one kind, and remaining R are distinct, right? So in this case, why is it different from before? Let's take a look. So when we were finding all possible arrangements of the word random, we said there will be 720 words, right? 6 factorial. We have 6 letters, so 6 factorial words were possible. We could form 720 words. Now, out of these 720 words, one of them would be random and another one would be RNADOM, where let's call them letter 1, letter 2, letter 3, letter 4, letter 5 and letter 6. So one word is letter 1, letter 2, letter 3, letter 4, letter 5, letter 6, and another word is letter 1, letter 3, letter 2, letter 4, letter 5 and letter 6. Right? These are two different words and we are counting all such words, and we said that there are 720 words possible. But if we say in a similar way that there are 720 words, 720 arrangements possible for this, in that case, let's look at this example again. So if we call this letter 1, letter 2, letter 3, letter 4, letter 5, letter 6, so this is one word arrays. And another word we are saying is when we swap letter 2 and letter 3 and the rest remain the same. So in this case, if we swap letter 2 and letter 3, it again becomes ARRAYS. We counted these two as two separate words, but in this case, these are identical. There is no difference between the first R and the second R, right? No matter which R we write first, it's going to be the same word. So in that case, we have to eliminate the words. We are definitely counting a lot of words repeatedly. We are repeating, we are counting them again, we are double counting perhaps. So how many times these words are being repeated? Now be very careful, listen, it's very important to understand. You can easily memorize the formula, but it's much more important to understand where that formula is coming from. Okay, so 100% concentration, you're going to listen exactly what I'm saying, and I hope you are able to understand and follow. So that means for every such word, we are counting twice. One when first are in this position and second are in this position, and repeatedly when those words, those letters are swapped. They end up being identical. That means how many arrangements of these two R's are there? 2 factorial, right? So 2 factorial, that is 2. So there are two ways of arranging first R and second R. If we call them R1 and R2, then we can arrange first R1 on the left and R2 after R1, or the other way around, R2 on the left and R1 after that, right? There are two possible permutations, but actually they are not different. They are not R1 and R2. They are identical. So there are going to be 2 factorial words where we are counting them as different R's, where they are actually the same. Similarly, for the A's are also identical. We are doing the same thing for A's as well. So multiplied by 2 factorial. 2 factorial words are being treated as like 2 factorial times. Each word is being counted 2 factorial times, and then again each word is again being counted 2 factorial times for these two A's. So let's say total actual possible number of arrangements for this was X. So we are counting these X words 2 factorial into 2 factorial, that is 4 times. It was only X, but we are counting them 4 times, so it actually became 4X. So this is how this 4X was what? 720. These 6 factorial words, we were counting these X words 4 times. So X actually comes out to be 720 by 4, which is 180, right? So that is nothing but 6 factorial by 2 factorial, 2 factorial, right? Because we were counting each of these X words 2 factorial times for the 2 R's, and then again 2 factorial times each of those words, again each 2 factorial times for the 2 A's. So like this, that means we had to do the entire n factorial divided by the number of repetitions, their individual arrangements. So for the formula we get, if I just erase this part, then the formula that we get is n factorial divided by p factorial and q factorial. So in general, whatever we have identical repeated, we will take the n factorial like before, n, where n is p plus q plus r. The entire total number of words that we have, we take all possible arrangements. But we know that because some of the objects are identical, we're counting them again. So we will just divide those by individual repetition. So if it were, let's say, P1 of one kind, P2 of one kind, a second kind, P3 of second kind, third kind, P4 of fourth kind, like this, we have something like this situation. In that case, we will have n factorial by P1 factorial, P2 factorial, P3 factorial, P4 factorial, and so on. So no matter what kind of objects they are, if a certain group is identical to each other, then we will divide that number of objects that are identical to each other, its factorial. Okay, so the formula should be clear, but it also should be just as clear how we reached this formula. Okay, so the most important thing to remember here is this formula. We will just take all the objects, all the arrangements, and then divide it by the number of repetitions that we have. Let's take a look at an example. It will be much more clear. So now we have 3 digits, 1, 2 and 2, and we have to form 3-digit numbers. That means we have to arrange these 3 digits. So our n is 3. So we have to do 3 factorial, but 2 of the objects are identical, so we will just divide it by 2 factorial. So this becomes 3 into 2 factorial by 2 factorial, which is 3. If you want to just confirm, because it's such a small number, we can just check. We have 3 digits. One can be in the first position, or one can be in the second position, or one can be in the third position. And once we have fixed 1, the remaining 2 are 2s. There is no other way of forming the number possible, right? So total only 3 numbers, which is what we are getting. Okay, so the formula should be clear, as well as how we reached this. Let's take a look at another example. Now we have 4 digits. We have to form 4-digit numbers out of this. So we have to arrange all of this just like before. Entire 4 digits, so 4 factorial divided by these 3 2's are identical. So 3 factorial, which is 4 into 3 factorial by 3 factorial, so 4. So just like before, one can be in the first position or second position or third position or fourth position. If we fix the digit 1, then the other digits will be 2, just like before. So only 4 different options for the digit 1, and that means only 4 possible numbers. So we have also confirmed it. Okay. Now, how many words can be created by rearranging the letters of the word Mumbai? In such cases, whenever we are given a word, you have to make sure that you're writing all the letters that are there. So how many letters? This is a small word, so you can easily calculate that there are 2 M's and the other are distinct. But in general, it helps that you start writing. First letter is M, second letter is U, then third letter is M again. So M is, the count for M is 2. Then B 1, A 1, I 1. So we have counted all of them correctly. So now total how many letters are there? 1, 2, 3, 4, 5, 6. 6 factorial divided by, only 2 of them are identical, the rest are distinct. So by 2 factorial. So this becomes 720 by 2, 360. Alright, so this is how you can do it. Now this was a fairly easy word. Let's take a look at a longer word. If we have the word mathematics, we're going to follow the same method as before. We'll start with M. So the count is 1, A 1, T 1, H 1, E 1, then M again 2, A again 2, T again 2, I, it's a new one, 1, C 1 and S 1. So now we have this count of every letter. Now total number of letters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Just want to confirm the count. You can do it from here as well. 2 plus 2 plus 2, 6, 7, 8, 9, 10, 11. So yeah, we've counted them all correctly. So the total number of arrangements will be 11 factorial divided by 2 factorial for M, 2 factorial for A, 2 factorial for T, and the rest are distinct. So it's fine. And this is our final answer. This is the number of words that we will get by rearranging the letters of mathematics. Okay, if you want to calculate you can, but it's very important to understand how it's being calculated. Now, if an insect wants to travel from square A to square B, from the top left square to the top right square, then we have a grid, a net of sorts, which is 5 cross 3, right? So we have 15 total squares. How many ways are there to go from square A to square B? The condition is it has to be shortest possible path. Now that doesn't mean you will go directly like this. They can only travel, the insect can only travel from one square to another. Either right or left, up or down. Okay? So right, left, up or down. It cannot go sideways. That means if it wants to reach this square, it will have to go either like this or like this. Okay? So first right, then down, or first down, then right. So how many total ways are there of reaching A to B? It can go like this, or it can go like this, or it can go like this. So there are a lot of ways clearly. How do we calculate? And why is this thing here with the rest of our slides? We were just talking about the arrangements, but this seems to be a very different problem, right? Or is it? So if you think closely, how do we calculate this? This is a small grid. Maybe we can count all possible ways in some order. But what if it were a very large grid? What would we do then? So if we think about it, in order to reach from A to B, it has to follow the shortest path, which means it cannot take such a path where it goes here and then back and then here and then here. Something like this. Now this is taking extra steps, right? Because it went forward and then it went back and then it's going forward again. Took extra steps. It has to go 1, 2, 3, 4. 4 squares right and 1, 2, 2 squares down. It has to go that much, right? Otherwise it cannot reach B. But anything more than that will not be the shortest possible path. So for example, if you check any of these orange paths, it's taking 4 rights and 2 downs, right? For example, if we say this, 1 right, 1 down, 2 right, 2 down, 3 right, 4 right, right? So 4 rights and 2 downs it has to take. But in case of the red route, it's going 1 down, 2 down, 3, 1 right, 2 right, and then 1 up, an extra step, 1 left, and then 1 up, and then 2 right and 1 down, and 1 right, 1 down, clearly much more than just 6 steps. So that is what we mean by shortest possible path, that they should not, if once they have gone forward, once the insect has gone forward, you don't want the insect to go back, it will take a longer path. Okay, so is that clear? What we mean by shortest path, what do we have to do? So we have to take 4 rights and 2 downs, right? 4 rights and 2 downs once we do this in any order, whether it's, for example, this first one that we just saw, it was right, then down, then right, then down, then right, right. So we arranged 4 rights and 2 downs like this. Or let's say this second, the topmost path, in that case, we are doing 1 right, 2 right, 3 right, 4 right. So right, 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 and then 1 down, 2 down. So down, down. So that means now it must be clear. All we have to do is arrange these 4 R's and 2 D's in any order, as long as it's doing 4 R's and 2 D's, it's going to reach B, which means we have to arrange these 6 digits, 6 letters, 6 directions, 6 steps, whatever you want to see this as, but basically these 6 letters R and D, where 4 of them are of one kind, 2 of them are of one kind. So this comes out to be 6 into 5 into 4 factorial divided by 4 factorial into 2, 4 factorial gets cancelled, and we get cancelled 2 as well, so we are left with 15. So 15 possible ways of going from A to B, as long as it's taking the shortest possible path. Okay, so with this we are done with today's class. I hope now you are clear with arrangements. Just practice as many as you can. How many ways of arranging? Try to come up with questions on your own. It's definitely going to help you. And I will see you in the next class with another advanced topic. Alright? Okay, can you explain? I see some doubts. So, if condition is not allowed, does that mean like it doesn't have to take shortest possible path? If it can take any path, then you want to find the number of ways? Okay, if that is your question, I am not sure. Okay, so if that is your, okay, yes, that is your question. So that means I will just erase this. Now, very good. If you're asking, ki, ma'am, what if the insect did not have to take shortest possible path, then how many ways of reaching B? It can go from here to here to here to here to here, or it can go from here and then back here and then here. Does that give you a hint? That means no matter how many ways we count from A to B, it can always come back to A, and then another way will be added to the list, right? So it can come back to any square and then it will act as a new path. So that means there are infinite ways of going from A to B if it can just keep going back and forth, back and forth. What ifs as simple as it started from here and went here and then back here and then went here and back here and back here. So it can do this infinite number of times, and then for the last one it will reach B. So it can do this 2 times or 3 times or 4 times, any number of times. So that means there are infinite ways of reaching from A to B if it can take as long a path as it can. So that is why infinite number of ways, that is why we had to mention that the insect has to take shortest possible path. Alright? It's 2 downs or 3 downs. Actually, one down will bring it to this square, another down will bring it to this square. This is why we have 2 downs. And one right will take it to second square, 2 rights to third square, 3 rights to fourth square, and 4 rights to fifth square. So it's going from position 1, 1 to 5, 3, or rather 3, 5. It's going from 1, 1 to 3, 5. That means what is the difference? 2 down and 5 minus 1, 4 right. Okay? Chalo, we'll end the class here. Tomorrow we'll have the next class. Same time at 3 p.m. and it will be scheduled. If it's not live yet, it will be live very soon. So just practice. If you want more questions to practice, I will make sure that by this evening I will give you some practice questions for you, but otherwise you know you have the resources. You can practice from a bunch of different places, different books, different modules if you are a student. So definitely keep practicing. Maths is nothing without practice, and I will see you tomorrow. Bye. Oh, you want a JEE question? Definitely. Okay. That's an interesting thing. Fine. I will bring a JEE question tomorrow that you can solve just by the given questions, the given theory. You can solve a JEE question, a difficult one. So it will be helpful for you. Okay. I will see you tomorrow now. Bye.